Okay, the next section has us using the addition formula rather than reciting them mostly. So worked example, using a suitable angle formula, show that sine of 15 equals this. Okay, how are they having surds here for something that's normally really, really messy? Well, the way that they're doing it is they're rewriting 15 as a subtraction. So sine 15 must be the same as sine of 45 minus 30 inputted into sine, okay? Because 15 is the same as 45 minus 30. No calculator stuff going on here, okay? I'm just saying that 45 minus 30 equals 15. Now, how did I know that? Well, if I see numbers like 15 or 75, I'm thinking they're connected to 30 and 45. Why? Because these are exact values that we need to know. And the topic, think about the topic, is about addition and subtraction. So this is a subtraction, isn't it? And the rule for a subtraction is what? Sine of the first one, cos of the second one. Sine copies the same sign again. So that must be cos of 45, sine of 30. Now it's starting to make sense why it looks like that, because I know there's some stuff here about a half and root 2 and so on. So let's do root 2 over 2. Cos of 30 is going to be root 3 over 2. Minus cos of 45 is root 2 over 2. Sine of 30 is a half. Okay, lots of ways you can finish off this question, but I noticed that they have 4, so it seems like a good idea to multiply them. So 2 root 3 over 4 minus root 2 over 4. Can you see root 3? Well, you're basically there. Okay, so that's the same. So that should be root 2. Root 2, root 3 is the same as root 6, and so on and so on. So pause the video and have a go. Use the rules here. So 15 is going to appear in very much the same way. And 75, well, you need to use 30 and 45 again, don't you? So pause the video and have a quick go there. And working out very similar to what we've done. Okay, you don't necessarily have to write it exactly as they have. And for tan as well, you can do the same sort of thing for tan. So sine, cos, and tan are not just abstract things that we type in the calculator anymore. We're thinking about the connection between sine, cos, and tan a little bit more. Okay, and if we know some values like cos 45, cos 30, if we know these kind of values, we don't have to resort to the calculator necessarily. Okay, challenging question, this one. So, just sort of take your time with this one. So we're going to continue with that idea now, that we can use different pieces to find out something else. So given that sine of A equals this number, okay, so we know what sine of A is, all right? And A is, well, A is a reflex angle. It's between, well, it's even narrower than that, isn't it? It's a particular type of reflex angle between 180 and 270. That's all about angle A. B, this is a different angle. B is obtuse. In other words, B is between 90 and 180. So it's the same sort of thing again. B is obtuse, and cos B, okay, so they're telling me another value here. What do they want? They want cos of A minus B. So that seems like a good place to start because we know a rule about that. So cos of A minus B is equal to cos, sine, different sign. So cos A cos B plus sine A sine B. Okay. Well, what do we have? We have sine A already, and we have cos B already. But you'll notice there's an obvious problem. We don't have cos A, and we don't have sine B. So that must be what this other information is for. So what can we do? Well, I'm going to start with cos A. If I draw a cos graph, it looks like this. Now, this is cos A. Do I know anything else about A? I know that A is between 180 and 270. Well, that's 90, that's 180, and that's 270. So I'm looking at this part of the graph because A is between 180 and 270, and this is what the graph of cos A looks like. So I'm expecting some kind of negative answer. Okay, so this is about A. Let's call this cos A. I'm going to do the same with. What's the other one? B. So look, sine B. And again, this isn't obvious why I'm doing this yet. You just have to trust me for a second. So this is a sine graph. And B is obtuse. Well, that's 90. That's 180. So B is sort of like here somewhere. We're talking about a positive answer. This is for sine B. Now, that doesn't give you any definite answers, but it tells you, for example, that this must be negative and that this must be positive. Because what I'm going to do to find out cos A is I'm actually going to use sine A. Remember, sine squared theta plus cos squared theta is always equal to 1. So if I want to find cos A, well, I'm going to change this. So I'm going to say sine squared A plus cos squared A equals 1. Now, sine squared A, I actually know what sine A is. It's minus 3 over 5. So if I square that, this is the same as 9 over 25. Plus cos squared A equals 1. Now, in my head, I kind of do this. I think of 1 as 25 over 25, and I say, what's missing? Well, what's missing is 16 over 25. So cos squared A equals 16 over 25. That means that cos A, when I square root both sides, must be positive or negative 4 over 5. So that's just by using my sine squared cos squared identity. Now it might make sense why I've done this graph over here. Well, what is it? Is it positive 4 over 5 or negative 4 over 5? It's negative. We know because we were given some information about the angle and we drew the graph. So cos A is minus 4 over 5. Okay, that's the process. Quite a lot going on there that you might need to sort of like check that you're happy with. My advice would be to find out the pieces that you're missing, to draw the graphs, and then they give you an idea of what the answer should be. The answer itself, I would use the identities. There are sometimes other ways to do it, but if you learn this method works for acute angles, obtuse angles, reflex angles, and so on. So let's just fill this out a bit more. Cos B, I think we were told that's minus 12 over 13. Sine A is minus 3 over 5. And look, sine B. I'm going to have to do the same thing again. So I'm going to do sine squared B plus cos squared B equals 1. I don't know what sine squared B is, but I do know that cos B is 12 over 13. If you square that, that's 144 over 69. 169. And then again, I sort of think about, what's missing? Well, what's missing is should be 25. Okay, so sine squared B equals 25 over 169. Okay, so sine B, running out of space here, is plus or minus 5 over 13. Well, if you look at the sine B graph, we're talking about this section here, so it must be positive. So I want the positive 5 over 13. So the final part is you multiply, simplify, blah, 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 blah. Clean all of this up here, and you will get your answer. Okay? Now, that is going to require some practice. Okay? For tan, you very much do the same sort of thing for tan. Okay? You will need tan A. You will need tan B. So where they're going to come from, this is one more step, is you're actually going to do sine A divided by cos A, aren't you? And notice you've got both of those values already from this question. For tan B, you're going to do sine B, which again, you've already got. You've worked it out, or you were given it, over cos B, which is the same situation again. So I'm just going to reveal that for you so it's a little bit neater. So earlier we found out these ones here. You can find these out with a division, and then you just you put all of these values into this to find this one out. Okay. And there's just a neater copy of the one from above. A different techniques being used here. So if you have acute angles, which you do, you can in fact draw a right angle triangle because 90 is the biggest angle that you have. You can do it that way, but you can also answer all of these questions using the same technique as before. And that takes you towards the end of 7b, so using the addition formulae.